So now again we'll continue with the lens and mirror. So this is the use of say we are using the mirror, we are using the lens, or both or we can use the combinations, not only use of mirror, lens, or maybe in the prism. Okay, so these are the combinations we can use in the optical instrument. So these are the optical instrument. Okay, so in this topic, so under this optical instrument, we'll basically talk about the telescope, and we talk about the microscope. Okay, so let's say object A makes an angle θ2 with our eye. Okay, so what is this? θ2 is the angle made by object A with eye. Means basically we are talking about eye lens. Okay, similarly this angle θ1. Okay, so θ1 is the angle made by object B with eye lens. So you see here in the picture, on the picture is clear that the height of A and height of B is same height. Okay, but it makes an angle θ2 with our eye and θ1 with our eye. Okay, so this means in our situation θ1 is less than θ2. So for our eye it appears as B appears as smaller and A appears as taller to our eye. Okay, so this means the angle is the important factor to determine the height, and this angle we see these are the name we may call the visual angle. Okay, so the role of all optical instrument is to increase the visual angle. Okay, so for example, this example shows here is the simple magnifier, is also called the simple microscope. Okay, so in this case we want to increase the visual angle. Okay, so let's define some of the term here. Okay, say here, because we are dealing with angle, so we call it magnification, but it is the angular magnification. Okay, say for example, okay, so just for example, we'll consider the case of this lens. Okay, we can consider the example of this lens. So without using any equipment, this object is making an angle of object theta. Okay, so let's draw this picture over here. So I draw my rough sketch of eye. This is my eye lens. Okay. This is the principal axis. This is the retina. So as you see in the picture, I put object at the near point. So height is h0, height of object, and it makes an angle theta naught with our eye. So this is, say, this angle is theta object. Okay, so this is the visual angle without using any equipment. Okay, so this object is situated, you know that to so clearly it should be at the near point. So it is at near point. So this angle, in this case, we haven't used any equipment. So this is the theta object, is the visual angle. Visual angle without equipment, okay? Without equipment. Without equipment. Say, and from this picture, we can write 10 theta object equals h0 over the this distance from the center of the, so this is the near point. So I wrote this distance as d. You can use any symbol. So this is the d, but you know this d equals nearly 25 centimeter for normal eye. Okay, if this angle is small, if angle is small, we can use the concept that 10 theta is nearly equal to theta in the measurement of the radian. Okay, so this means I can write theta object equals h0 over d. So this is the angle without using the equipment or lens. So we don't have lens over here. Now we are putting a convex lens in between object and the eye lens. Okay, so let us draw the picture again. So how it looks like. Now, say for the lens, we can draw the picture. Say now I have this lens. So I'm assuming here that this lens, convex lens is convex lens close to eye lens. Okay, so our situation will be like here. Even though it's so up some distance, we are assuming they are close. Okay, so if this object we put, object is here, okay, of height yet not height of object, say its focus is over here, focal length. Okay, so we use focal length f having this lens. So you know that after refraction, it forms the virtual image. So one ray parallel to the principal axis, other ray through the optical center. It will not meet anywhere, so we need to produce back it will meet somewhere. So this is the image, but you know that this image will be not real. This is a virtual image. Okay. Now you see that visual angle is increased to our eye. Okay. Now this object, be careful that it's not at um, at the okay, at the object position, is not at, may not be at the point, okay, in the near point, but just write that it is between focal length and optical center of this lens. Okay, let's do up. So for this lens, now the angle will be different. This angle will be now different. This angle is theta. Let's see what symbol we have used in our original picture. Okay, so this angle is now different. Okay, so I say that now this is the theta image. So this is a virtual image of height, say h1. So be careful that if we talk about, just I'm writing the note, if we talk about linear magnification, if I'm talking just the positive value magnitude, it will be h1 over h0, okay, or equal to object distance, this is will be d0, and image distance will be di. Okay, so di over d0. Okay, so this is the magnification, but we call it the linear magnification that we did here. But we define here is the not the linear magnification. It will be the angular magnification. Okay. So again, now be careful that this is not at the near point. Okay, so we define this ratio of we define the ratio here for this magnification. We define the ratio is called angular magnification. Angular magnification. We can write any symbol, but I'm just writing M, capital M. So this will be the ratio of theta image over theta object. But this angular measurement must be in the radian. So this ratio is called the magnification, but it is angular magnification. So clearly it has no unit. Okay, just for note, I will write here again. We can simplify further here, like theta image will be equals to theta image will be equals to theta 10 theta image will be nearly equal to theta image as before, and we can consider this as S0 over D0. We can write S0 over S0 over D0, S0 over D0 and this also equals to h1 over di, h1 over di. Okay, so we can use either equation to simplify further. So using this equation, we can find yeah, or for a simple lens, simple microscope. Okay, let's move further about the compound microscope. In the case of compound microscope, this lens is close to objective. This lens is close to objective, close to objects. That's why this lens is called the objective lens. Okay, and the final image is formed somewhere, maybe at infinity, or maybe at the maybe at the 25 centimeter from the eye. So this lens, you see, is close to eye. So this is called the eyepiece. So we have two lenses basically in the compound microscope, the objective and the eyepiece. So simple word, we call it the objective and eyepiece. Okay. So in this case, you see that final image is at 25 centimeter, means this is the near point. This is the near point from eye. Okay, let's draw the picture how it looks like from the beginning. Okay, so I started with say I have common principal axis. So this is my objective lens. Okay, this is objective lens. Okay, then I put an object, I put an object beyond its focal length. Say it is here. Okay, so it will form an image. Okay, we can draw a picture like this. So it will form an image. One ray parallel to principal axis passes through the focus. Okay, the other ray through the optical center, it goes straight. So it will be, image will be formed somewhere here. Okay, so this is the image. This is the image position. Okay, this is the image position for objective. So this is the we just write here that just you saw above. This is the image position for objective lens. Okay, so because we want our final image at 25 centimeters from the eye, so it must be not real, it must be the virtual image. So I say its height of objective, we can choose height will be, say, for example, h. Okay, let's see what symbol we used. So height is h. So this height is h. Then height of the image is h1. Now we want to find the image at 25 centimeters from the eye. So I put the another lens over here. My picture not looks good. So I will try to make a good lens. Okay. So this should be under the focus point for eyepiece. Okay. So this is the eyepiece. This is just the name of the lens. So you know that rays parallel to the principal axis. Say this is focus for eyepiece. So F, I write E. So from equal distance, I need roughly. So it is FE. Okay. So you know that one ray again parallel to the principal axis passes through focus. Okay. Another ray from optical center passes through this. Okay. Then if you produce this ray, it will meet somewhere. Okay. So let's say meet here. So the image will be formed, final image. This is the position of final image. My image is not up to scale. So image will be formed of height h1 prime. This is the final image. So be careful that this is image for objective, and at the same time, this is object for eyepiece. And this one is the final image. Final image. Okay. So now, once we did this thing, then we can find, we can use some of the equations to find the magnification. Okay. So this is the final image. So you can use the equations as before. So for objective lens, you can use your lens formula 1 over object distance plus 1 over image distance equals 1 over focal length. Okay. So in this picture, I would write, say, this distance will be d naught, object distance, and image is formed here. So this distance will be di for eyepiece, so for objective. This distance will be, say, d for distance for eyepiece, de. Okay, we can use the other symbol, say d object, d, say do prime, and final image is here, so we can use, this is di prime. Okay, so we can define those all symbols that we have. Okay. So for the objective lens, we can write this equation 1 over d naught plus 1 over di equals 1 over f naught. Similarly, we can write the ratio of height is equals to the height of image distance and object distance. Okay. Similar equation we can write for the eyepiece. Okay. So for the eyepiece, we can write the similar equations. So here you have seen that this is the height of object. So this is for the eyepiece, okay? And this will be the height of image. Okay, so our next goal is to find this magnification, angular magnification. So we know that angular magnification we defined as before is theta prime over theta. Okay, so in picture, let's say our theta prime is with the eye. Our eye will be here somewhere, very close to the eyepiece. So this angle, okay, this angle will be theta prime. Okay, so we need to find angle theta prime and theta. So let's see our angle, this angle theta prime. We can use this small triangle, or we can take this big triangle. So it will be you can write as tan theta prime equals h1 over d naught prime, okay? Or we can use tan theta prime equals hi prime over di prime. We can use either one. So this can be written as, for a small angle triangle, theta equals h1 over d naught prime. And similarly, we can use theta prime equals hi prime over di prime, right? So we can use either one. So this is basically I everywhere. Let's see. This is, we have to replace accordingly, okay? So everywhere. So we figure out this angle. So next job is how to find theta. Okay, so theta, if you remember, this is our, if I draw the eye lens over here, this is my eye lens, and this is the retina. If I put the object of same height, okay, same height as the previous case for objective height h, okay, height h, and it kept at d. So d is roughly, I just use the symbol d to represent the near point distance. It is 25 centimeters, and it makes an angle theta, visual angle theta in this case. So I can write tan theta equals h over d. Okay, so as before, I can write theta equals h over d. Then you can find, then we can use the above result. Then we can find m. This is the magnification, but angular. This em is angular magnification using theta prime over theta. Okay. Let's, this is all about the compound. So this is all about the microscope, but we use the two lens, so it is called the compound microscope. Okay. Next, we can see how we can deal with the telescope. Okay, so we have the telescope is used to view objects on the Earth surface, or space, both. Okay, if you use this telescope to view the object at Earth. It is called terrestrial telescope. And if you use this to view the to view the object at space, is called the astronomical telescope. Okay, astronomical telescope. So again, the main principle will be same, but you should be careful that in the case of microscope, we use this to view a tiny object. Okay, but in the case of telescope, we use to view basically very big object, but they are at very far away, either on the Earth surface or on the space. Okay, so we'll talk about this taking one example. Okay, so in this case, the final image at infinity. You see that? Okay, and in this example, you see the final image is at the case of near point. So we can produce the picture final image at near point or at the far point. Sorry, at the near point or at infinity. But the basic principle will be the same. Okay, so we'll talk about. So I'm going to draw an example. So let's see. In this case, say I have one telescope over here. Okay, this is my objective lens. So in this time, I have say object is not near, they are very far away. So the rays coming from very far away will be parallel, but it may or may not be parallel to the principal axis. So I'm taking this example. Rays are very far away coming from infinity. So my object at infinity. Okay, so you know that rays at infinity means image will be formed at focus. Okay, so this will be the position of image. Okay, this is image position. So I say it as I indicate this as HI. This is the focus point for objective. So if I want my final image at infinity, so for final image at infinity, focus point of eyepiece will be at the same position as F naught. Okay, this means what? I want final image at infinity, so I will keep my other lens eyepiece in such a way that focal length, focus point of eyepiece will also be at the same point. So this distance is f naught. This distance is fe. Be careful that they are not same. It looks like same here. So f naught is not equal to fe. So figure is not on a scale. That's the reason. So you know that if this is the case, we have to, this is the image for objective and object for the eyepiece. So one ray parallel to the principal axis will go through its focus to the other side, and one through the optical center also pass straight. So you see that they will not going to meet anywhere. So final image will be at infinity. So we assume that two parallel rays meet at infinity. Okay. So they meet at infinity. This means final image at infinity. Okay. Our eye is somewhere here. So again, I want to make clear is that this one is object or eyepiece, but at the same time, image for objective. Image for objective. Again, our goal is to find the magnification, angular magnification. Angular magnification. So m, again, we need to figure out as theta for object image over theta for object. Okay, so let's see. So in this picture, because objects are at very infinity, so we can consider this angle as theta for object, and our eyes here this time we can consider this angle as theta for image. So as before, we can take the small angle. Okay, so for a small angle, so this is equals to 10 for the simplification purpose, theta image over 10 theta object. Okay, we can simplify that. So for example, you can find what is theta image, what is 10 theta object, and simplify further, and finally we will get here. Okay, so as a note, you can just for the purpose of not purpose, if you consider for objective, your object is at infinity, so 1 over infinity plus 1 over say d objective equals 1 over focal length for objective. If you consider for eyepiece, it will be okay. It will be 1 over d for d naught prime. Final image is as infinity equals 1 over fe. So in this picture, we can say D naught. Okay, so clearly you can see here, this is D naught or DI, sorry, DI maybe. So it is DI. I generally use the I symbol for image position. DI, this is object, so D naught. So in this picture, this will be DI, D up, D. Yeah, the image, and this will be the object. So just write by. Okay. So we can simplify further and find all this math. We can do this math because to find the geom, we need to use this equation and this equation. So if you understand up to this point, you can solve this problem. And at the same time, you can see how the camera work. So there are one important concept about AF number. Okay, so how the camera works. So in this case, we are not talking about the camera. We're not talking about the digital camera. We are talking about simple camera. So we are not talking about that. We are talking about only simple camera. Okay, so you can see more detail in the book or in the link at the end of the slide. Okay, so here are the link to find for the various topics. For example, like how this camera work, you will be find under this optical instrument link.